Welcome to qnawire.
In this problem, we need to find the angular velocity of the rocket immediately after the lanyard is taut. So I have here a sketch of the problem. So a 7 meter by 1 meter rocket with mass 4,000 kilograms was released from rest until the 2 meter lanyard was taut. So when the lanyard was taut, an impulse is produced at point B, as you can see in the second part of the diagram. And the rocket rotates with an angular velocity omega, and the mass center moves with a velocity v with components vx and vy, as you can see in the last part of the diagram. So while the lanyard is slack, the rocket falls freely without rotation. So considering its motion relative to the airplane, we can solve for the vertical velocity using the equation. So v squared or v2 squared final velocity equals the initial velocity plus 2g times the displacement. So since it was dropped, so we have our initial velocity is 0. So v2 is equal to square root of 2g times the displacement. So this is equal to 2 times 9.8 meters per second squared times y, which is the length of the lanyard, so 2 meter. So 2 meters. So that would be equal to 6.264 meters per second. Now, applying the impulse and momentum theorem, we'll have, for the x component, so we'll have 0 plus 0 equals mvx. So this tells us that vx is equal to 0. Then for the y components, so we have vy equals 3.5 omega. Because as you can see in the diagram, so the center G is at a distance of 3.5 meters away from point B. Now, solving for the moments about point B, taking the counterclockwise direction as positive, so we'll have the equation mv1 times 3.5 plus 0 equals I omega plus mvy times 3.5. So, substituting the values that we have in the equation for the moment of inertia, which is actually based on the shape, so I equals 1 over 12 times the mass times the dimensions squared, the sum of the square of the dimensions. So, our equation will be, or this becomes, so 4,000 kilograms times 6.264 meters per second times 3.5 meters. So equals, so 1 over 12 times 4,000 kilograms times the dimension, so 7 meter squared plus 1 meter squared, and then times omega, then plus, so again 4,000 kilograms times 3.5 meters times omega times another 3.5 meters. So simplifying the both sides of the equation, so the left hand side would be equal to, so 87,696, and then the right hand side would be equal to 65,667 times omega. So therefore, omega is equal to 87,696 over 65,667. So this is equal to 1.335 radians per second.